Hi, this is Tom Reardon, math teacher from Ohio. Here we're going to look at how to use CAS, a computer algebra system, to help students learn how to solve linear equations. For this video, we're going to use the CAS on the TI-Nspire CAS CX handheld, shown here. We could also use the CAS on the TI-Nspire CAS app for iPad. We could also use the TI-Nspire CAS teacher or student software, and other computer algebra systems would work in a similar way. Here's the plan. We want the student to do each step on paper and then check his or her work with the CAS. In this way, the students can learn from their mistakes, work at their own pace, and not be embarrassed when making a mistake. We're also going to use the CAS to assist in checking the solution. The solution is not a nice number, not an integer. Here's our first example. Solve and show that your solution does check. So if you look at the equation here, there are several options on what we could do. We could subtract 2x from both sides, we could add 7 to both sides, subtract 5, add x, and a lot of other transformations that wouldn't be helpful but would work. So for this one, I'm going to go ahead and add x to both sides. Now before I do that though, the student would copy this on their paper, do the first step, type this in on a calculator page in TI-Nspire CAS, press enter, and now we're ready to go ahead and use the CAS. So again, we're thinking of adding x, so on the calculator I'm going to go ahead and press plus, meaning add, and it says take the last answer, and the last answer is right here, and I want to add, in this case, x to both sides, and I'll press enter to do that. The notation the CAS uses is puts parentheses around the equation and then says add x. This is not the notation my students would use. They would actually show adding x to both sides. And hopefully this is the result they get. And if it is, great, continue. If not, immediately check for where you made your mistake and learn from it. So from this equation here, most of us would probably add 7 to both sides. So again, I'm going to press the plus sign. It says take the last answer, which is this equation, and add, in this case, 7 to both sides. Press enter. And we get 3x equals 12. And again, students would have better notation than this. If this is not the answer they got, they would need to work towards that. And then finally, we would either divide both sides by 3 or multiply by a third. And it's taking that last answer, 3x equals 12, dividing each side by 3. And I do like how, well, no, I don't really like how it shows there. I would like it showing as two separate fractions, but an x equals 4, and that's our solution. Now we do want to show that it checks. Hopefully students could do this one mentally, but if you needed to show it, I have that showing on the next page. So this is the equation. Here's our solution. Everywhere we see an x, we'll replace it with 4. And on the left-hand side, we get 2 times 4 minus 7. 8 minus 7 is 1. Right-hand side, 5 minus x, which is 4, is 1. And since 1 equals 1 in identity, this solution does check. And that means the number 4 is the number for the variable that makes the equation true. And how I have my students write the answer is x is equal 4 because 1 is equal to 1. That way I know they did in fact check. And this is what I just basically said. You can pause if you want to. Here's our second example. Solve and check this equation. This one I do need to, this is on the calculator page. So the student needs to actually type in 10x plus 1. The equal sign is over here. 3x minus 8. Press enter. And now we can use the CAS here. And again, we have many, many options. And I'm going to make some mistakes in this one to show you what happens when students do that. So for this one here, I'm going to go ahead and subtract 3x from both sides. So I'm going to press the minus sign. The last answer is this whole equation. Subtract 3x from each side. Press enter. This is the result. the student made a mistake, they could correct it. If they got it right, they can continue. And here again, we'll subtract 1 from both sides. So I'm going to press -1. And some of my students, I think when they would subtract -8 minus 1, might get -7. So this hopefully will help them catch arithmetic mistakes as well as algebraic ones. And we got to here, which is perfectly valid transformation, and they're here. And I have some students, unfortunately, that'll say to get rid of the 7, which is not what I want them to say, I will subtract 7 from both sides. So they'll subtract 7, they'll do that. Now they'll think they'll get the answer as x equals -16 by subtracting 7. Here, this comes back with this, and some of them will go, oh yeah, I need to divide by 7, but the ones who don't actually have to figure out what happened here. Why didn't that get rid of the 7? And so this is definitely a teaching or a learning moment for them. Now this was a valid transformation, keep that in mind, it just wasn't one that was helpful. So they could either continue from here or go from where they were last. Most students will press the up arrow to go back to the equation they were that they liked last. Press enter to bring it down and press enter to now put it back in the system. And now we're going to go ahead and divide both sides by 7. And we get an answer of x equals -9/7. To check this one is not going to be very nice. It would be hard for students to do by hand or mentally for sure. So there are a couple different ways to do this. I'll show one here and I'll show another way on the last exercise or last example. So what I need to do is everywhere I see an x in the original equation, I need to replace -9/7. So I have 10x plus 1, so I need 10 times whatever x is, which in this case is -9/7, right parentheses, plus 1. So I'm evaluating the left-hand side. The right-hand side was 3x minus 8. So it's going to be 3 times -9/7. And I like to use parentheses to surround the variable in this case. And that was 3x minus 8. And when we do that, we get -83/7 on the left, -83/7 on the right. So we're very sure that this is the solution. And my students would write x equals -9/7 because I get -83/7 equals -83/7. And that way I know they did check. All right, moving on to the last example, because I wanted to illustrate some other things on the last example. Here we're asked to solve and check. I already typed it in on a calculator page. I'm going to press enter to get it into the system. And here, again, I'm going to subtract 8n from both sides. Perfectly legal transformation. Students will do this on their paper. If they get this, fine. If not, check it. And here I've got students that will subtract 5 from both sides to, quote, get rid of the -5, which is, of course, incorrect and a bad way to say it, too. But I'm going to go ahead and do this because they'll do it and get like -6n equals 12. Okay? So I'm going to go ahead and do the subtract 5 from both sides. And they'll go, oh, that didn't get rid of the -5. And hopefully they'll see why. -5 minus another 5 is -10 or -10. So here they could either, they have a valid transformation, they just don't have one that helped them. So they could either go back to this equation or proceed from this one because they are equivalent equations. Okay. So let's just go ahead and add 10 to both sides. Let's just go from this one. And then finally divide both sides by -6. And get n equals -11/3, and hopefully that's what they got. I would like to show you another way to show the check using one of my favorite keys, the such that key. The such that key is where the equal sign is. It's one of the ones on the equal sign. The such that key is right there, so we'll come back to that. So for this one here, I'm going to go ahead and take the left side, 2n minus 5, and write it as 2n minus 5. Use the such that key, which is control equals, and this is the such that key. And I'm going to go up and use the up arrow key to go and highlight the solution, n equals negative 11/3, and press enter. And what it does is it copies and pastes it down and says, evaluate this expression such that n is this number. And I'll press enter. I'm getting negative 37/3 on the left side. The other side was 8n plus 17. So I'm going to type 8n plus 17. Use the such that key. And again, go up and highlight the solution. Press enter to paste it down. And again, this says take the left side and evaluate it such that n is this number. And again, we've got an identity. So the solution is n equals negative 11/3 because I get negative 37/3 equals negative 37/3. Now, the reasons I like to use CAS to assist students in solving linear equations is, first of all, it helps them to learn the procedure without getting bogged down with other things. It catches their arithmetic mistakes that often bog students down. It helps students find their errors and correct them immediately. They get instant feedback, good feedback. They can try alternative paths, say, what if I would have done this to both sides, and see what would have happened, and kind of investigate and explore. And also I like it just because it's student-paced, and it's like having a teacher sitting there right with them, telling them, no, this is what you should have gotten, and help them find their mistakes. If you're interested in finding out more about how to use CAS to help teach middle and high school students mathematics, there is an International CAS conference in Cleveland this summer, July 18th and 19th. I'm helping to organize it, and I would love to see you there. We're going to have experts, CAS experts from all over the United States, as well as ones from Australia, Austria, Scotland, Canada, and hopefully another country or two. So here's the contact information. If you use all lowercase letters, bit.ly/CAS_Cleve, it'll take you to that, or you can contact me via email. Thank you very much.